All right, I'm going to show you how to integrate two very specific functions because those functions show up repeatedly, and I want you to see the pattern that happens when you have that certain one of those two types of functions, because it's going to make your job a lot easier. You won't have to think as much about finding the answer to this type of problem once you recognize the type of function that it is. So the first one of these two functions is anything that's of the form e to the ax plus b. So I want to go through, first of all, talking about the derivative of a function that looks like that. So for example, e to the 2x plus 7. Well, if I take the derivative of e to the 2x plus 7, first I take the derivative of e to the something, and that's e to the something. Then I take the derivative of that something, the 2x plus 7, and that's what gets me that 2 in front. So the derivative of e to the 2x plus 7 is 2e to the 2x plus 7. And what that means, or another example of that would be that the derivative of, let's say, e to the negative 9x plus 3, again, it would be e to the negative 9x plus 3 times the derivative of negative 9x plus 3, which is negative 9, and that explains this extra negative 9 out in front. And one more example, just to show you, so you can see a pattern, is that the derivative of e to the 0.4x plus 1.1 would be 0.4 e to the 0.4x plus 11, or that should be a 1.1. So what that means is, in general, if I have the derivative of e to the ax plus b, that's going to be a times e to the ax plus b. Whatever x is being multiplied by, that's going to be sticking out in front of the derivative. What that means is, if I go backwards and start at a times e to the ax plus b, the antiderivative of that is going to be get you back to e to the ax plus b plus a constant. Don't forget about that, plus c. All right, but if the a isn't there, let's say I just had a function that was e to the ax plus b, then I need to divide it out of the answer as well. So what that means is, in general, the antiderivative of e to the ax plus b is 1 over a times e to the ax plus b plus my constant. Okay, so let's just quickly do some examples of that. The antiderivative of e to the 9x plus 13 would be 1/9 e to the 9x plus 13 plus a constant. E to the negative 10x plus 1, the antiderivative of that would be negative 1/10 times e to the negative 10x plus 1 plus c. And the third and final example that we're going to do of this type is the antiderivative of 12 times e to the 1/2 x plus 3/4 is going to be 12. Remember, you can pull out that 12, and then 1 over 1/2 e to the 1/2 x plus 3/4. And all of that has a constant added to it. So if I wanted to simplify that even more, the answer would be, hopefully you can get it before I can, 24 e to the 1/2 x plus 3/4 plus c. So that's any function that's of the form e to the ax plus b. The other type I want to look at is anything that's of the form ax plus b to the n. So again, I want to start by looking at derivatives. The derivative of, let's say, 2x plus 3 to the 4th, if I can get it to line up. First, you would take the derivative of the exponent 4, so the derivative of that would be 4 times 2x plus 3 all to the 3rd. Then, using chain rule, you would have to take the derivative of 2x plus 3, which is 2. So the derivative would be 8 times 2x plus 3 to the 3rd. Another example, the derivative of 5x plus 6 to the 8, for example, would be 8 times 5x plus 6 to the 7. Then I multiply by the derivative of 5x plus 6, which is 5. So the whole thing would be 40 times 5x plus 6 to the 7. And then the last example we're going to do, just looking at the derivative of negative 4x plus 7 to the negative 9 would be negative 9 times negative 4x plus 7 to the negative 10, multiplied by the derivative of what's in the parentheses, so negative 4. So the whole thing would be 36 times negative 4x plus 7 to the negative 10. All right, so in general, the derivative of ax plus b to the m is am times ax plus b to the m minus 1. Okay, so hopefully you see that pattern there. If I'm working backwards, that means that if this is what I'm taking the antiderivative of, then I'll get back to ax plus b to the m. So in other words, the antiderivative of am times ax plus b to the m minus 1, which is what I have right here, the antiderivative of that would be ax plus b to the m plus c. And again, I need to ask myself, what if the am wasn't there? Well, that means that I still have to add 1 to the exponent, and I still have to divide by a and the new exponent to get backwards. So if this was what I started with, to get m minus 1 to be an m, I have to add 1, and since that a and m are not there, I have to divide them out, which is okay since they're both constants. So in general, if I had the antiderivative of ax plus b to the n, I would have to add 1 to the exponent, and I would have to divide by a, and I'd have to divide by my new exponent. And don't forget the plus c. So just to do some quick examples, if I had the antiderivative of 12x plus 9 to the 7, I would raise the exponent by 1, divide by the new exponent, and also divide by the x coefficient of 12. And that would give me 1 over 96 times 12x plus 9 to the 8th plus c. And one last example, if I had 2x minus 3 to the negative 1, and I wanted the antiderivative of that, again, I would have to follow a whole new set of rules, because if I add 1 to the exponent, I would get 0, and I would have to divide by that 0. Well, that's not something that we can do. So we have to remember that the derivative of the natural log of x is 1 over x. So whenever you see an exponent of negative 1 and you're asked to find the antiderivative of that, there should be a little bell that goes off and tells you, oh, this is not the usual situation where I add 1 to the exponent and divide by the new exponent. This is a case where I'm going to have to use the natural log. I'm still going to have to divide by the x coefficient of 2. So my answer will be 1/2 times the natural log of 2x minus 3 plus my constant. So hopefully those examples help. If you have any questions, let me know. Otherwise, I will see you tomorrow.